All right, so today what we're going to be talking about is sinusoidal models, okay? Essentially, basically what that is it's word problems with trig functions, okay? So we're going to learn how to read carefully, write down what we see, and pick the important things out, okay? Reading is going to be incredibly important. You have to know how to read. How many times do we read a word problem? How many times do we read a word problem? Seriously? Yeah. 3 times. Yeah, you read it once to kind of get the gist of the question and pull out your important information. You read it again to make sure that you're doing what they're asking you to do. You read it a 3rd time when you're all done to make sure you've answered everything, to make sure you rounded appropriately. 3 times. Okay? Reading is very, very, very important. I can't stress that enough. Awesome. You're going to learn. Okay. So, the sine and cosine functions can be used to model real-world phenomena that are periodic. That is, they repeat in predictable patterns. And we've already talked about what periodic and what cyclic mean, right? The key to constructing or interpreting sinusoidal models is understanding the physical meaning for the coefficients. And we've talked about that in depth. We know A, that the coefficient out front is our amplitude. We know B, right in front of the x, is our frequency. We know if we add something to the end of the function, that's our midline. So we've talked quite a bit about that, okay? So just a reminder, okay? A, or the absolute value of A, is our amplitude. We know that already. The distance a sinusoidal model rises or falls above or below its midline. C is the midline, or the average y value, God bless you, of the sinusoidal model. B is your frequency. Frequency means how many full curves you get between 0 and 2 pi. What does period mean? How long it takes to get one full curve, okay? So that's the difference there. All right, so let's look at the first one, okay? Now, we're going to read this carefully, and what I'm going to ask you to do is in your notebook, since you have them out already, because every day since we've started doing trig, we've needed them out because we draw pictures, right? Okay, so you're going to read through this. We're going to read through it together. You're going to read through it once on your own. I want you to write down all of the important information that you read, okay? So, it says, the tides in a particular bay can be modeled with an equation of the form D equals A times cosine B of t plus C, where T represents the number of hours since high tide, and D represents the depth of the water in the bay. The maximum depth of the water is 36 feet. The minimum depth is 22 feet, and high tide hits every 12 hours. All right, so I want you to reread it to yourself, and I want you to write down all of the important information that you read, and then we'll talk. Okay, so who wants to tell me what they wrote down? The equation, which is? Great. And then what? T is hours since high tide. Okay. Okay. Maximum depth is what? All right. Okay. And what does that 12 hours represent? We get, awesome, say it again. It's period, yeah. If we get high tide every 12 hours, that's how long it takes to get one full cycle. Great, nice job. Okay, so we got a whole bunch of information, right? So if I want to come up with the equation here, A cosine B times T plus C, I need A, B, and C, right? What does A represent? Amplitude, great. B, frequency, and C, midline, great. All right, can I find all that with the information I have? Sure. All right, so let's start with amplitude. How do I find amplitude? Awesome, max minus min divided by 2. All right, that's amplitude. What else can I find? Midline, how do I find midline? Max plus min divided by 2. Great. And what's the last one I need? frequency. How do I find frequency? Yeah, 2 pi over b. The b is my frequency, right? I know what the period equals. Period equals 12. So I can find frequency from that. So I want you to take a few minutes, and I want you to find those 3 things. Okay? Okay, so what'd you get for amplitude? 7, good. So we did max minus min divided by 2 gives us 7 what? Feet. Okay, you always want your units. Okay, midline, what'd you get? I'm sorry? 29 feet. Great. All right, how do we use the formula for period to determine frequency? Set it equal to 12, good. Sure, we could put that over 1. Cross multiply, which is going to give us, yeah, 12. Which gives me b equals pi over 6. Excellent. So my frequency is pi over 6. So that means I have pi over 6 full curves between 0 and 2 pi. Okay, I know it sounds funny, but it'll make sense in a moment. All right, so from all that information, what we're able to do is we're able to write our trig function, right? Our sinusoidal function. So d equals 7 cosine pi over 6 t, good, plus 29. Excellent. Wonderful, wonderful. Okay, so there's our function. We're not done. I know you wish we were, but we're not. All right, so that wasn't bad, right? You guys think you could have done that on your own? Okay, so let's get a little harder. I'm not kidding. I never kid about these things. Okay, we're going to go back to the lesson here. So on a, hello. Put that back in there. On a set of axes, we are going to sketch the graph of the scenario for 2 full periods. Okay, we're going to verify, 2 full periods. We're going to label the points on the curve that represent high tide and low tide. All right, so we want 2 full periods, right? So I know 1 period is what? 12. So how many, what am I going to have to go to? 24. All right, so we're going to sketch the curve. Are you guys ready? All right, graph paper, horizontal. Now, don't put the axes on yet. I want you to think about how we're doing this before you throw some axes on there, okay? We got all of this information so that we could sketch the curve. That was the point. Okay, now, what is my maximum height? 36 is my maximum, right? What's my minimum? 22. What's my midline? 29. Okay, so I know that I'm going to be way up here, right? So do I need to deal with negative y values at all? No, absolutely not. Okay, so let's think about my domain. Domain in this case is what? What variable are we discussing? Time, okay? Time is my domain. So if I think about time, am I going to talk about negative time? No, it wants us graphing 2 full periods, so we want to be between what and 24? 0 and 24. Okay, so my axes, okay, my y is going to go almost all the way to the left. I need the arrow on the other side. That's okay. Okay. My x is going to go where? Am I going to put it right through the middle of the page? I'm going to put it very low, okay, because I need to go somewhat high in order to get my maximum and my minimum in there, okay? Oh, my board is off. Okay, so let's think about how we're labeling our domain and our range. What is our range? What's our range? What would go on our y-axis? No, not numbers. Depth, right? The depth is our range here. So we need to label with a D. You have to be appropriate with your labels, guys. We're not talking y and x anymore, are we? No. Okay. we said our equation that we want to sketch is this, right? So what is our domain? T. Time in terms of what? Hours. And depth was in terms of feet, right? So we want that information. It's going to allow us to answer things more clearly. All right, so now we need to label our axes. We need to put some units in here, right? Time. How much time are we using? 12 will give us 1 period. We need 2 periods, 24 hours. Thank you, Stephen. Okay, so all the way at the end, we should have our 24. Break it up however you need to. If you want to go by ones, go by ones. I think you all probably have enough to go by ones. Okay, so go ahead and you're going to go all the way to 24. Since I don't have, I'm just going to put in my so you need to go to 24. Wherever you need to be for 24 is fine. Let's think about our depth. What's our deepest depth, I guess you could say? 36. So how high should I go on that axis? Give yourself a little wiggle room. Let's go to 40. Okay. So however you need to go is fine. You can go by 2s, you can go by 3s, whatever works for you. Okay, so when we're graphing a trig function, what's the first thing we like to put in? Before we put in the zeros, if it has any. Somebody said it. Draw the midline. Yeah, we want to put that midline in to start, right? What was our midline? 29. Good. So we're going to go ahead and put my midline in to start. All right, because remember, our midline is what we're going to basically revolve our function around. Okay? Our midline is very important. Okay. Now we're talking about cosine, right? Does cosine start at its maximum or at its minimum? Starts at its maximum, right? We know cosine, and I'm just going to sketch it down here so you guys can remember. Cosine kind of looks like this. All right, so it starts at the maximum and it ends at the maximum. Halfway in between, we find the minimum, okay? So what's the maximum? 36, okay. So we start at the maximum and we end at the maximum. So where am I going to find 36 again? At 12. So that's the end of the first curve. And then where again? 24. Good. Excellent. Looks like I'm going to be a little off. That's okay. Okay, so I start at my maximum, I end at my maximum. What's halfway in between? My minimum. What's my minimum? 22. Great. Where am I going to find 22? 6. So 622. And where else? And 18. Very good. And for me, it's a guesstimation because I don't have lines that I'm using, guys. So I apologize if I'm a little off. Yeah, 18 because it's halfway in between 12 and 24. Okay. Is that even? All right, good. Okay, so from that we can sketch in our cosine curves. Okay, so that's 2 periods, right? The first period is from 0 to 12. The second period is from 12 to 24. All right, now, the problem asked us to do what? Let's go back. What does part A tell us to do? Yeah, sketch the graph, 2 full periods, and label the points that are high tide and low tide. Okay, high tide and low tide. Where do we find high tide? At our maximums, right? So I'm going to label these HT, which is high tide. And where do we find low tide? Minimums, LT. Okay. I'm also going to make sure, well, I've got my function labeled. Okay, make sure your function is labeled if it isn't already. All right, with the formula, with the equation. I'm sorry? That's fine. Okay. Notice I didn't extend past 0 or 24 with arrows. They're having us graph on a specific interval. They only wanted 2 periods. I do not need arrows. Okay, they specified their domain. They told us what they wanted. No arrows. Got it? Okay. All right, so let's read part C. I'm sorry, part B. Determine the values of A, B, and C in the model. Verify your answers and sketch. Verify your answers and sketch are correct on your calculator. That doesn't make sense, does it? Sketch to make sure it's correct on your calculator. So we should be good with A, B, and C. We did that already. We're going to use our calculator to sketch this out to make sure that our sketch on paper is appropriate. Okay? So you're going to learn how to do that. So from here, I want everybody to insert a graph page. Control-I. Add graph. Okay. And we're going to put in our function, 7 cosine in the trig button. It's next to the equal sign. Got it? Okay. 7 cosine pi over 6. And what variable do I need to use? X, okay? Plus 29. Control G, up, and you can change. Why doesn't it show up? Yeah, it's high, right? So I need to adjust my window. So let's talk about our windows. We're going to start at X minimum. I'm going to double click to open that text box so I can adjust. Okay, so double click on that -10. We're going to open that up and we're going to adjust it. What was the minimum X value that I used on our graph? 0. Excellent. So we're going to change that to 0. Do not hit enter. Did you already hit enter? That's okay. You can double click on it again, open it back up. Okay. Now to get to the next field, I'm going to hit tab. That's going to bring me up to Y maximum. What was the maximum Y value I used? 40. Great. Tab. We'll bring you to the next one. Okay. Tab again is going to bring us to our X maximum. What was our maximum time that we dealt with? 24. Good. Tab again. What was my minimum depth that I used when we graphed it on paper? When we graphed it on paper, what did your, how about 0? Okay, 0. Because look, guys, I started at 0, did I not? Okay, 0. All right, so does it look like our paper? Yeah, sure. Okay, so we're good there. Your paper looks better? Okay, I'm glad. Okay, be right there. All right, so I'm going to go back a page here. I want you to read part C, okay? Think about what they're asking. No, you're fine, honey. That looks good. Okay, tanker boats cannot be in the bay when the depth of the water is less than or equal to 25 feet. Set up an inequality and solve it graphically to determine all points in time t on the interval from 0 to 24 when the tankers cannot be in the bay. Round all times to the nearest tenth of an hour. Okay, I got my equation, right? That equation represents the depth of the water in the bay over time, okay? So as time increases, my depth is going to go down and up and down and up. This equation represents that depth. I'm saying that the tankers cannot be in the water when the depth of the tanker or the depth of the water is 25 feet or less. Okay? I need to figure out when those times occur. So how could I graphically show that? Awesome. Draw in a line at 25. Okay? So do that on your paper and label it d equals 25. Solid line. Yep. Okay? That's going to show me when the depth of the water is 25 feet. My concern is I cannot be in the water. The boat cannot be in the water when the depth of the water is 25 feet or below. Okay? So what am I looking for? Yeah, I'm looking for this interval and this interval, right? Because I know that's when I'm 25 feet or below. So how can I solve this graphically? What am I looking for? Somebody said it before. I just need you to speak up again. What am I looking for? How do I solve this? Yeah, I'm looking for these points. I'm looking for the points of, what's the word? Intersection, right? I'm looking for the points of intersection because those points of intersection are going to tell me at what time I'm going to hit 25 feet and below. That's what I'm looking for. Okay? So, on your calculator, graph in the line of d equals 25. So Control G brings back up my function bar. 25, enter. So again, I'm looking for what? The points of intersection. So go ahead and find me my points of intersection. How do I do it? Menu. Geometry. Points and lines. No. Intersection points. Menu, geometry, points and lines, intersection points. The reason I use this one instead of the other one, this one will give me all of my intersection points at once. Okay? So click, click. And if you need to move them so they're easier to see, you can do that just by grabbing and moving. Okay? All right. So now I want to write in interval notation. You guys heard of that before, right? I want to write in interval notation the times at which the tanker cannot be in the water. Intervals at which the tanker cannot be in the water. So we said that from here to here, I can't be in the water. Why? It's too low. The water's too low. And again, from here to here. So the x-coordinate of these points represents what? The time at which it's what? Equal to what? The time at which it's equal to 25, right? So I know when the water's 25 feet, can I be in the water? No, absolutely not. If it's less than 25 feet, can I be in the water? No, absolutely not. Okay, so essentially what we're doing is we're solving an inequality. I'm solving this. Okay? Solving an inequality. Okay, so interval notation. What's interval notation, guys? What do I have to use? Yeah, the brackets, the closed or the open bracket. Okay, so am I going to be using closed or open? Closed, good. What's my first number going to be? Yeah, and I'm going to go to the nearest tenth, so 4.2. So at 4.2 hours, okay, all the way to 7.8 hours, I can't be in the water. Okay, and again, when can I be in the water? Not the and. Yeah, union. Union. Okay. When do I pick it back up? Good. And all the way to 19.8. Okay. So those are the times when the tanker cannot be in the water. Okay, that's when the function is less than or equal to 25. Yeah, these are long. Okay, so that completes this problem. I want to get through one more with you guys. Your homework is going to be to do questions 3 and 4 in this lesson. Okay? Okay, you ready for the next one? All right, this next one's easier. Okay, the height of a yo-yo above the ground can be modeled using the equation h equals 1.75 cosine pi t plus 2.25, where h represents the height of the yo-yo in feet above the ground, and t represents the time in seconds since the yo-yo was first dropped from its maximum height. So it's starting at its maximum, cosine curve, right? Determine the maximum and the minimum heights that the yo-yo reaches above the ground. Show the calculations that lead to your answers. Part B says, how much time does it take for the yo-yo to return to its maximum height after it's first dropped? All right, so first we want the maximum and the minimum. How do we determine maximum and minimum from a given equation? Not for midline, okay? So to find the maximum, I have to do what? Add what? Midline plus amplitude. How do I find the minimum? Good, midline minus amplitude. Rise or fall, above or below, right? So find the maximum, it's midline plus, minimum, midline minus. That's part A, right? Part B says, I want to know how long it takes to get from my maximum height when I first drop it back to my maximum height. So what am I looking for? I'm looking for the period. Good. How do I find period? Good. Can I find all that information given what I have? Yeah, absolutely. What's midline? I'm sorry, what's my midline? 2.25, yeah. What's my amplitude? What's that equal? For what? Feet, yeah. Great. So my maximum height is 4 feet above the ground. Okay? No. That's if you're looking for it from a graph, honey. Okay? All right, minimum. Midline minus amplitude, which is going to give us a value of, 0.5 feet. Okay, so that's part A, not bad, right? Okay, part B says I want to know how long it takes to get one full swing of that yo-yo, right? Up and down, or down and up, I guess I should say. Okay, so 2 pi over B. What's B represent? Frequency. What's my frequency? Pi. Remember, frequency is always whatever's in front of that variable. Okay. 2 pi over pi, yep. Oops. Pi does not have 3 lines, does it? No, it doesn't. Okay, 2 pi over pi, pi's cancel. 2 seconds, very good. Great. What do you think? Yeah, number 2 is much easier than number 1, right? Yeah. Okay, so your homework is number 3 and number 4 in this document. Okay, so you're going to do those on a separate sheet of paper, and I'm going to collect them tomorrow. You have 2 problems. Now, I sent you a corrected weekly project. Your weekly project was missing numbers 1 and 2. So you have a new weekly project in your weekly project folder that says weekly project 14 correct, okay, or corrected, either way. So please do that one. That is the one I will collect. Got it? Yeah. Tuesday, yeah. Your midterm review is due Tuesday. You've had that for a little over a week now. Your weekly project is due Tuesday as well. You can come in and see me, absolutely.